Good day, friends, and welcome to today's WASE online channel. I'm Philip, your instructor. But before we start our lesson for today, I need you to subscribe for our channel if you've not already done that. We need your subscription for the survival of this program. To do this, just go below this video and tap the subscribe button. Thank you so much for doing this for us. Now let's look at our activity for today. So today we'll continue with bearings and vectors. We are on part 5 of this topic. And under this part, we'll be looking at the following. 1. Inverse or opposite of vectors. 2. Parallel vectors. Then 3. Perpendicular vectors. Let's start by looking at the inverse or the opposite of vectors. To better understand the meaning of inverse or opposite of vectors, we would use numbers to illustrate what opposite of numbers are. So let's take the number 3. The opposite of the number 3 would be negative 3. The number 7. Its opposite would be negative 7. Now let's take the number negative 9. Its opposite would be 9 or positive 9. Now let's take the vector AB. What this means is that the opposite of the vector AB would be negative AB. So if the vector AB is equals to xy, then the vector negative AB would be negative xy. Negative xy simply means that the negative sign is multiply the x component and the y component. So when the negative sign multiplies the x component, you would get negative x, and when it multiplies the y component, you get negative y. So what this means is that if vector AB is equals to xy, then its opposite vector, which is negative AB, should be negative x, negative y. Now, I need you to pay attention to what I'm going to say. The negative vector AB can be written in another form without showing the negative sign. So all we will need to do is to flip the vector AB into the vector BA. So let's note that the vector BA is the same as the vector negative AB. Let's summarize what we have just learned. So if you have the vector AB to be equals to xy, its opposite can either be negative AB, which is equals to negative x, negative y, or BA, which is also equals to negative x, negative y. Remember that the negative AB is the same as the BA. Let's solve some examples. Find the inverse or the opposite of the following vectors. Example 1. Vector AB is equals to 3, 4. Its inverse or opposite will be equals to either negative AB or BA, and that will be equals to negative 3, 4, which is the same as negative 3, negative 4. Example 2. We have the vector GK equals to negative 4, 5. Its opposite would either be negative GK or KG. That will be equals to negative of the vector negative 4, 5, which will also give us 4, negative 5. Example 3. We have the vector IU equals to negative 2, negative 8. Its opposite would either be negative IU or UI, which is also equals to the negative of the vector negative 2, negative 8, which would also give us the answer 2, 8. Let's look at parallel vectors. Parallel vectors. First, we would have to look at what parallel lines are. Parallel lines are lines that would never meet. And the reason why parallel lines will never meet is because at any point in time, they have the same distance between them. So we have these three lines. Lines A, B, and C. And they are parallel lines. And here the assumption is that the distance between the line A and B at any point in time is the same. It doesn't change. The same applies to that of C with respect to either B or to A. So the distance between them doesn't change. It continues like that even if the line is extended to forever. Now, apart from the fact that parallel lines do not meet because they have the same distance between them, there is something you need to also know about parallel lines, and that has to do with what you call their slope. To determine the slopes of these three parallel lines, let's draw an horizontal line on top of them. So these angles are the slopes of our parallel lines. What you need to note about the slopes of these parallel lines is that they are the same. So the slope of the line A is the same as that of the line B, and it is also the same as that of the line C. The reason is they are parallel. So let's note that parallel lines have the same slope. Slope is also called gradient. Again, I will need you to note that parallel lines do not always move in the same direction. There are instances when parallel lines move in opposite directions, although they still have the same distance between them. So it's also something you really need to note. And we'll be making use of this very information when we look at parallel vectors. So note that parallel lines can move in the same direction and they can move in opposite directions. Now let's apply what we have just learned in parallel vectors. When we were looking at parallel lines, we said that parallel lines have the same slope or gradient. What it means is that parallel vectors also have the same slope or gradient. To calculate the slope or the gradient of a vector, we use the following formula. Slope of a vector is equals to the y component of the vector divided by the x component of that same vector. So if we have the three vectors A, which is equals to 3, 4, B, which is equals to 6, 8, and C, which is equals to -6, -8, we should be able to calculate their slopes because we know their x component and their y component. All we need to do is to substitute those components into the formula. So for vector A, its slope will be given as 4 divided by 3. Since the y component of vector A is 4 and the x component of the vector A is 3. The gradient or slope of vector B would be given as 8 divided by 6. Since the y component of vector B is 8 and its x component is 6. But we can break this number further. The 8 over 6 can be broken further to 4 over 3. For vector C, its gradient will be given by -8 over -6. Since its y component is -8 and its x component is -6. And when we break this further, we would get 4 over 3. Now, what can you say about the slope or the gradient of these three vectors? It's obvious these three vectors have the same gradient or slope. We have already learned that parallel vectors have the same slope or gradient. So what this means is that the vectors A, B, and C are parallel vectors. So calculating the slopes of vectors can help us determine whether two or more vectors are parallel or not. However, this method of determining whether two or more vectors are parallel or not has a disadvantage. When we were looking at parallel lines, one of the things we said was that parallel lines can move in the same direction. They can also move in opposite directions. This method, like we've already said, can determine whether two or more vectors are parallel or not. But it cannot determine whether they are moving in the same direction or they are moving in opposite direction. But I will still advise that you use this method to determine whether two or more vectors are parallel or not, especially if the question you are solving does not demand that you determine the directions of the vectors involved. The reason is this method of determining whether two or more vectors are parallel or not is the easiest. In our next slide, we'll be looking at another method that can help us determine whether two or more vectors are parallel. Now, this method would also be able to tell us whether those vectors are moving in opposite directions or they are moving in the same direction. So let's jump into it now. I believe we have not forgotten about what scalars are. For that matter, what scalar multiples are. So to remind ourselves, we said that scalars are simply numbers which would usually multiply vectors. They could be whole numbers, they could be integers, they could be fractions, they could even be decimal numbers. And I mean, because these numbers are not vectors, they are scalars. And one of the things we said about them, which wouldn't be necessary here, was that they have only magnitude, they don't have direction. But that particular information, we will not need it here. We will be more interested in how scalars would multiply vectors to form other vectors. Remember, when a scalar multiplies one vector, usually another vector is formed, and that new vector that is formed is called the scalar multiple of the first vector. So that is what you need to understand. So let's take, for example, the vector A. This vector has the components 3, 4. Now let's take the scalar 2. What we are going to do next is to multiply the scalar 2 by the vector A. When we do that, we would get 2 times the vector 3, 4. When we multiply the scalar 2 by the vector 3, 4, we would get a new vector which is 6, 8. I have named this vector vector B. Because we got the vector B by multiplying a scalar to the vector A, we would say that the vector B is a scalar multiple of the vector A. Now, this is where I need you to pay attention. I will need you to remember all the time that a vector and its scalar multiple are always parallel. And in this case, the vector A and the vector B, one is a scalar multiple of the other. So what it means is that the vector A and B are parallel. So let's write this down. Two vectors are parallel if one of them is a scalar multiple of the other. Kindly pay attention to the next thing I'm going to say. Now, in this example we just looked at, the scalar was a positive number. In fact, it is positive 2. Always, when a scalar is a positive number, what it means is that the two vectors involved, the vector and its scalar multiple, are moving in the same direction. If this scalar were to be a negative number, let's say negative 2, what it means is that the two vectors involved are moving in opposite directions, although they are parallel. Now let's look at an example to illustrate what I have just said. Now let's take the vector A equals to 3, 4. Let's assume that to get the vector B, we would have to multiply the vector A by the scalar 2 or positive 2. We would also assume that to get the vector C, we would have to multiply the vector A by the scalar negative 2. So the vector B would be equals to 2 times the vector 3, 4, which is the vector A. And the vector C will be equals to negative 2 times 3, 4. We already know how to multiply scalars by vectors, so let's quickly do that. First, we are doing the vector B. So 2 times the vector 3, 4 would give us 6, 8. So our vector B is equals to 6, 8. Let's do that of the vector C. Negative 2 times the vector 3, 4 would give us negative 6, negative 8. So now we have three vectors. Vector A equals to 3, 4. Vector B equals to 6, 8. And vector C equals to negative 6, negative 8. I believe we know that the vectors B and C are scalar multiples of the vector A. And we also know the reason behind this. Well, the reason is very simple. For us to get the vector B, we multiply the vector A by the scalar 2. And for us to get the vector C, we multiply the vector A by the scalar negative 2. That's why they are scalar multiples of the vector A. So from what we have learned so far, we can say that the vector B is parallel to the vector A. And the vector C is also parallel to the vector A because they are all scalar multiples of the vector A. Now, although the vector B and C are all parallel to the vector A, they are parallel in different forms. Now, whilst vector B is parallel and moves in the same direction as A, the vector C is also parallel but moves in opposite direction to the vector A. I believe you know the reason why this is so. The reason is simple. It's because the scalar that resulted in the formation of the vector B is a positive scalar, and that result in the formation of the vector C is a negative scalar. Now, if you have to use diagrams to represent what we have just said, the A will look like this. And because the vector B moves in the same direction as the A and it is parallel to the vector A, it would also look like this. So the arrow is showing that the two vectors are moving in the same direction. And as you can see, the distance between them at any point in time is the same. So they are parallel and moving in the same direction. The vector C is also parallel to the vector A, but then it moves in the opposite direction to the vector A. So it would look like this. Let's look at another illustration. In this illustration, let's look at these three vectors. We have the vector A equals to 3, 12. The vector B equals to 6, 24. And the vector C equals to negative 6, negative 24. The first thing we are going to look at is whether these three vectors are parallel. Now the question wants us to determine whether the vectors are parallel or not. It is not interested in any direction, so let's simply use the slope to do this. The slope of vector A will be equals to 12 over 3. I believe you know why it is 12 divided by 3. Remember, the slope or the gradient of a vector is always equals to the y component divided by the x component. So when you divide the 12 by the 3, you would get 4. Let's determine the slope of the vector b. It will be 24 divided by 6. 24 divided by 6 would also give us 4. The gradient of the vector c is equals to negative 24 over negative 6. This would be equals to 4. So all the three vectors have the same slope. This means that they are parallel. Let's look at another question. Which of these vectors move in the same direction as vector A? Since we are talking about directions of vectors, we have to use the scalar multiple method to find this. First, we already know that the vectors B and C are parallel to the vector A. So clearly they are scalar multiples of the vector A. That we already know. So what we would simply do is to find the scalars that were multiplied to the vector A for us to get the vectors B and C. Let's start with the vectors A and B. When you look at the vectors A and B, what do you think was the scalar that was used to multiply the vector A for us to get the vector B? Look at it carefully and answer that question in your head before I give the answer. Well, that scalar is 2. You'd realize that if you multiply the scalar 2 to the vector 3, 12, which is vector A, you would get the vector B, which is 6, 24. Let's now move on to the vectors A and C. Which scalar do you think was used to multiply the vector A for us to get the vector C? In this case, the scalar was negative 2. Alright, so can we answer the question now? Which of the two vectors, vector B or vector C, is moving in the same direction as vector A? The answer is very obvious. It is the vector with the positive scalar, and that is the vector B. Let's look at the final question. Which of the vectors move in the opposite direction to the vector A? Also, in this case, the answer is very obvious. It is the vector with the negative scalar, and that vector is vector C. Let's look at some examples. Example 1. Which of these vectors is parallel to vector A? So in this question, we have been given the vector A equals to 1, 3. And we have also been given other vectors from B to F. And we are being asked which of the vectors from B to F is parallel to the vector A. Since the question wasn't interested in the directions of the vectors involved, the easiest way is for us to calculate the slopes or the gradient of the vectors given to us. We also need to calculate the slope or the gradient of the vector A. We'll then compare the vectors that have the same slope as the slope of the vector A should be parallel to the vector A. It's as simple as that. So let's do that quickly. So first we'll calculate the gradient or the slope of the vector A, which will be 3 divided by 1. 3 divided by 1 would give us 3. The gradient or slope of the vector B will be equals to 18 over 6. 18 divided by 6 would give us 3. The gradient of the vector C would be equals to negative 3 over 2 divided by negative 1 over 2. When you solve this, you would get 3. The gradient of the vector D would be equals to 8 divided by 6. When you calculate this, you would get 1.3. The gradient of the vector E would be equals to 30 over 10. When you calculate this, you would get another 3. Finally, the gradient of the vector F would be equals to negative 45 divided by negative 15. When you divide this, you would also get the number 3. So what do you think? So we have the gradient or the slopes of all the vectors, the vector A, B, C, D, E and F. I want to find out which of these vectors are parallel to the vector A. So what it means is that we are going to look for those vectors that have the same slope as the vector A. Those vectors are parallel to the vector A. So let's quickly do that. The vector B has the same slope as the vector A. So it is parallel to the vector A. The vector C has the same slope as the vector A. So it is also parallel to the vector A. The slope of the vector D is completely different from that of the vector A. It is 1.3, while the slope of the vector A is 3. So what it means is that the vector D is not parallel to the vector A. The slope of the vector E is also 3. It is the same as that of the vector A. So it is parallel to the vector A. Finally, the vector F has the slope 3, which is also the same as that of the vector A. So it is also parallel to the vector A. I believe you found that interesting and easy. Let's look at example 2. Example 2. Which of these vectors is or are parallel and moves in the same direction to vector A? So in example 2, we've been given a list of vectors from B to F. And here we are being asked of two things. One, to find out which of them is parallel to the vector A. Then 2, which of them also moves in the same direction as the vector A. Since the question made reference to direction, what it means is that calculating gradients or slopes of these vectors wouldn't help us in any way. So we have to use what you call the scalar multiple method to be able to do this work. So let's quickly do that. In doing so, from the vectors A to F, we'll be looking for those of them that are scalar multiples of the vector A. And in doing that, we would also have to write the scalars that resulted in their formation. So that's what we are going to do. So we'll start with the vector B. The vector B, is it a scalar multiple of the vector A? If it is a scalar multiple of the vector A, then which scalar resulted in the formation of the vector B? Now, when you look at the vector B and the vector A carefully, you realize that you can get the vector B from the vector A simply by multiplying the vector A by the number 3 or by the scalar 3. So what it means is that the vector B is a scalar multiple of the vector A, and the scalar that resulted in the formation of the vector B is the number 3. Now we would have to compare the vector C to the vector A. And when you look at the two carefully, you realize that we can get the vector C from the vector A by multiplying the vector A by the number -4, which makes C a scalar multiple of the vector A. Let's move on to the vector D. Again, with vector D, you'd realize that it can be gotten from the vector A by simply multiplying the vector A by the number 5, which makes the vector D a scalar multiple of the vector A. Let's move on to the vector E. So we are comparing the vector E to the vector A. And as I compare the two of them, it does not seem like we have a number which can be multiplied by the vector A for us to get a vector E. So clearly what it means is that the vector E is not a scalar multiple of the vector A. Finally, we'll be comparing the vector F to the vector A. And whilst I do that, I'm unable to get a number which, when multiplied by the vector A, would give us the vector F. So what this means is that there is no scalar that will be multiplied by the vector A for us to get the vector F. So F is not a scalar multiple of the vector A. Next, we are going to use two steps to determine which of these vectors is parallel to the vector A and at the same time moves in the same direction with the vector A. The first step is to determine which of the vectors is a scalar multiple of the vector A. That would give us the indication that that vector is parallel to the vector A. Then the second step is to look out for those vectors which are parallel and have a positive scalar. Once you have a positive scalar, what it means is that you move in the same direction. If you have a negative scalar, what it means is that you might move in parallel with the vector A, but you are not moving in the same direction as the vector A. So let's look at that. We would start with the vector B. As shown on the screen, the vector B is a scalar multiple of the vector A, and its scalar is the number 3. The number 3 is a positive scalar. So what it means is that the vector B is parallel to the vector A and at the same time moves in the same direction as the vector A. Let's go to the vector C. The vector C is also a scalar multiple of the vector A. The scalar is -4. Now, what this means is that the vector C is parallel to the vector A. However, because its scalar is negative 4, what it means is that it does not move in the same direction as the vector A. So it might be parallel to vector A, but then it moves in the opposite direction. So the vector C cannot be the answer. Now let's move on to the vector D. The vector D is also a scalar multiple of the vector A because it has a scalar of 5, which when multiplied to the vector A will give us the vector D. And in this case, the vector D scalar, which is 5, is positive. So what it means is that D is one of the answers. It moves in the same direction as the vector as the vector A. We are now on the vector E. The vector E, we realize that it is not a scalar multiple of the vector A. So clearly it is not even moving in the same direction because we've already established that it is not parallel to the vector A. So it is also not one of the answers. And the same applies to the vector F, because the vector F doesn't also have a scalar, which means that the F is not a scalar multiple of the vector A. So it is also not one of the answers. So to conclude, what it means is that the vector B and the vector D are the only vectors that are parallel to the vector A and also moves in the same direction as the vector A. The rest are not satisfying this condition, so they can't be part of our answers. I believe you found that interesting and easy. Let's move on to example 3. Example 3. Which of these vectors is or are parallel and moves in opposite direction to vector A? So in this example, we are being asked to find which of the vectors from B to E are parallel to the vector A and at the same time move in the opposite direction to the vector A. So let's quickly do that. We are going to use 2 steps to solve this problem. First, we are going to determine which of these vectors is a scalar multiple of the vector A. Then we will also determine which of them has a negative scalar. Remember, when your scalar is negative, then it means that you move in the opposite direction to the vector A. So that's what we are going to do. So first, we determine which of them is a scalar multiple of the vector A. Now, when we look at the 2 vectors A and B carefully, you realize that the vector B can be gotten from the vector A by simply multiplying the vector A by the number -2. What this means is that the vector B is a scalar multiple of the vector A. Now let's go to the vector C. When you compare the C to the vector A, you realize that the C can be gotten from the vector A by simply multiplying the vector A by the number 2, which means that C is also a scalar multiple of the vector A. Now let's go to the vector D. We are comparing D to the vector A, and when you do that, you realize that for us to get the vector D, the vector A would have to be multiplied by the number -4. What this means is that the vector D is also a scalar multiple of the vector A. Finally, we are on the vector E. Is he a scalar multiple of the vector A? I'm trying to look for a scalar which, when multiplied by the vector A, would result in the formation of vector E, but I can't find any. So what it means is that the vector E is not a scalar multiple of the vector A. So from what we have done so far, it looks like the vector B, C, and D are all scalar multiples of the vector A. The vector E is not the scalar multiple of the vector A. So what it means is that we can just get rid of the vector E. It is even not parallel to the vector A. Now for the vector B, C, and D, the only ones with the negative scalars are the B and the D. Of course, we said that when your scalar is negative, then what it means is that you move in opposite direction. So they are the ones that move in opposite direction to the vector A and at the same time are parallel to the vector A. Now let's come to the vector C. Yes, the vector C is parallel to the vector A, but its positive scalar doesn't make it move in opposite direction to the vector A. In fact, because it is positive, what it means is that it moves in the same direction as the vector A. So the vector C cannot be one of the answers. With what we have solved so far, you should be able to solve any type of questions presented to you from parallel vectors. Let's look at perpendicular vectors. Perpendicular vectors. Now before we start, I'll need us to first note that perpendicular vectors are also called orthogonal vectors. Now let's look at the vectors A and B. Vector A is equals to 3, 5, and vector B is equals to 5, negative 3. I want us to calculate the slopes or the gradient of these two vectors. The slope of the vector A will be given as 5 divided by 3, and the slope of the vector B will be given as negative 3 divided by 5. Let's look at the slopes of the two vectors carefully. When you look at these two slopes, you would realize that one of them is the negative reciprocal of the other. The slope of the vector B is the negative reciprocal of the slope of the vector A. Now the truth you need to know is this: the two vectors A and B are orthogonal vectors, or they are perpendicular vectors. So what can you say about orthogonal vectors or perpendicular vectors? Well, let's write that down. If two vectors are perpendicular, then their gradient will be the negative reciprocal of each other. What this means is this: when you are given two vectors and you are asked whether the vectors are perpendicular or not, all you need to do is to calculate the slopes of the vectors. Now when you realize that the vectors have slopes that are the negative reciprocal of the other, what it means is that those two vectors are perpendicular or orthogonal. It's as simple as that. So in the next examples that we are going to look at, we are simply going to use this simple technique to determine whether two or more vectors are orthogonal or not. So that's what we are going to look at in the next slides. Example 1. Which of these vectors is or are perpendicular to vector A. Like we've already said, for a problem like this, we would have to calculate the slopes of all the vectors involved first. So let's do that quickly. The slope of vector A is 4 divided by 3. The slope of vector B is equals to 7 divided by 5. The slope of vector C is 6 divided by negative 8. We can break this fraction down further. When we do that, we would get negative 3 divided by 4. The gradient of the vector D would be 8 divided by 6. When we break this down further, we would get 4 divided by 3. The gradient of our vector E would be 6 divided by 8. When we break this down further, we would get 3 divided by 4. The gradient of the vector F would be negative 9 divided by 12. When we break this down further, we would get negative 3 divided by 4. Now, so at this point, we have been able to calculate the slopes of all the vectors involved. We also know that the vector that is perpendicular to the vector A should have a slope that should be the negative reciprocal of the slope of the vector A. Vector A's slope is 4 divided by 3. The negative reciprocal of this slope or of this number is negative 3 over 4. What this means is that all vectors with their slope of negative 3 over 4 are perpendicular to the vector A. The vectors C and F have the slope of negative 3 over 4. What this means is that they are perpendicular to the vector A. The rest of the vectors B, D, and E do not have this slope of negative 3 divided by 4. What it means is that they are not perpendicular to the vector A. I hope you found this easy and interesting. Let's look at example 2. Example 2. Which of these vectors is or are perpendicular to vector A? So as usual, we would calculate the slopes of all the vectors involved. The slope of the vector A would be 6 divided by negative 3. When you break this down, you would get negative 2. The gradient of the vector B would be equals to 4 divided by 8. When we break this down, we would get 1 divided by 2. The gradient of the vector C would be negative 3 divided by negative 2. When we break this down, we would get 3 divided by 2. The gradient of the vector D is 8 divided by 16. When you break this down, you would get 1 over 2. The gradient of the vector E is negative 10 over negative 5. When you break this down, you would get 2. Finally, the gradient of the vector F is negative 2 divided by negative 4. When you break this down, you would get 1 over 2. Now we know the gradient of all the vectors involved. We also know the gradient of the vector A to be negative 2. Now the negative reciprocal of this number would be 1 over 2. Also, all vectors that are perpendicular to the vector A should have this slope of 1 over 2. The vectors B, D and F have slopes of 1 over 2. What it means is that these vectors are perpendicular to the vector A. The vectors C and E do not have this slope of 1 over 2. What it means is that they are not perpendicular to the vector A. Now, let's look at the third example, which will be our final example on perpendicular vectors. Example 3. Which of these vectors is or are perpendicular to vector A? So first we would calculate the slopes of all the vectors involved. The slope of the vector A is 2 over 7. The slope of the vector B is 4 divided by 14. When you break this down further, you would get 2 divided by 7. The slope of the vector D is equals to negative 14 divided by 4. When you break this down further, you would get negative 7 divided by 2. The slope of the vector E is equals to 21 over negative 6. When we break this down further, we would get negative 7 divided by 2. We now know the slopes of all the vectors involved. The slope of the vector A is 2 over 7. The negative reciprocal of this number is negative 7 over 2. All the vectors with this slope, negative 7 over 2, are perpendicular to the vector A. The vectors D and E have the slope of negative 7 over 2. What this means is that they are perpendicular to the vector A. The vector B do not have this slope of negative 7 over 2. It is therefore not perpendicular to the vector A. Well, friends, this brings us to the end of part 5 of bearings and vectors. You can now move on to the part 6 of this topic, bearings and vectors. In this part, we'll be looking at the following topics: 1. Position vectors. 2. Expressing two given points as a column vector. And 3. Resultant vectors. Stay blessed, and thank you very much for being with us. And please, if you have not subscribed for this channel, kindly do so. Your subscription is needed for the survival of this program. Thank you once again. We will meet in our next video.